In this video, I'll be going over benzene reaction part 1. So if you have a benzene react with any normal molecule that you might use in an alkene, alkyne, or maybe an ether epoxide reaction, there's going to be no reaction. And the reason is, if you draw an energy diagram, you don't have enough energy for the reaction to proceed forward. This is primarily because benzene are very stable due to aromaticity and resonance. Thus, there's not enough energy for the reaction to proceed forward. However, if you have a strong electrophile, then the reaction can proceed forward because now there's enough energy for the reaction to proceed. So in any benzene reaction, there are 3 primary steps. The first step is generating your strong electrophile. So this is usually done by having 2 molecules react with another. You'll see these with each subsequent reaction. The second step is usually having some kind of nucleophilic attack. So this is usually done by having one of the electrons in the benzene here attacking the electrophile. And then the last step is having some kind of elimination reaction. So what this will usually be is having some kind of base or having some molecule basically doing an elimination reaction in which it's going to deprotonate a hydrogen, thus reforming aromaticity. So generally, if we were to draw in terms of actual molecules, after we generate our strong electrophile, which I'll note as E, we're then going to have a nucleophilic attack. So basically, this electron here is going to attack E+. So now we're going to form a molecule that looks like this. And as we can see, here is now the new plus charge. So in order to get rid of this plus charge, now we're going to do an elimination reaction. So if you remember, we have a hydrogen here, and we're going to have some kind of base. So this base is going to attack this hydrogen. This hydrogen is going to reform aromaticity, thus reforming this molecule. And this is the general mechanism for any benzene reaction. So for the first reaction, we're going to be learning about halogenation. So if we have a benzene and react it with Cl2 FeCl3, or if you want to do a bromination reaction, you can react it with Br2 FeBr3, then you're going to get this molecule with either chlorine or bromine on it, depending on which halogen you use. So as I said, there are 3 main steps to any benzene reaction. The first step is generating your strong electrophile. So if we have Cl2 react with FeCl3, what's going to happen is that this lone pair on the chlorine is going to attack FeCl3. Thus, you're going to result in a molecule that looks like this. In addition, don't forget that we now have a plus charge on this chlorine. So in order to get rid of this plus charge, this electron here is going to move to the chlorine, thus forming this molecule, Cl plus and ClFeCl3, or more commonly known as FeCl4. So now the second step is doing some kind of electrophilic attack. So what that's going to look like is you have a benzene here react with Cl+, and this Cl+ comes directly from this molecule that we just produced. So what's going to happen is that this electron is going to attack Cl+, thus forming this molecule. And now we have a plus charge here. And kind of the last step here is we need to somehow get rid of this plus charge. And the way we can do it is by doing some kind of elimination reaction. So what's going to happen is that this molecule that we have here, ClFeCl3, is going to be the one that does the elimination reaction. So specifically, ClFeCl3, and this electron here is going to deprotonate this hydrogen here. It's going to attack this hydrogen, and this electron on the hydrogen is going to reform aromaticity like so. So in the end, we now have this molecule as well as excess FeCl3. And that's kind of the mechanism behind this reaction.